we continue our work with functions by looking at some applications. And in these applications, we're going to talk about something called the practical domain and the practical range of the function. In previous videos, we have had equations of functions, or we've had graphs, we've had tables, and we've been asked to find the domain. In these application problems, we will be determining the domain based on the information given in the problem and also using some common sense as to what makes sense in the situation. For example, in number 1, you've got that the platform of a high dive is 42 feet above the water. A diver jumps from the platform and lands into the water after 1.3 seconds. The function h of s represents the height of the diver after s seconds. So let's take a look at that notation right there and see how the information that we're getting just from that sentence alone. We know from this sentence that the name of the function is h and that the input variable is s. So let's write that down. S is the input variable, and what does it represent? Well, it represents the time after the diver jumps. So this is time in seconds, and it's the time that it takes the diver to land in the water. So it's time that the diver is falling. Time after stepping off the platform. Now, in our function notation, the output variable is h of s. So h of s, which is the height of the diver after x seconds, that's our output variable. And it's represented in feet. Okay, and that's our output variable. We're asked to find first the practical domain of the function. So again, s is our input variable, and it is representing the time he's falling off the platform before landing in the water. So then our practical domain we can write using inequality notation, or we can write using interval notation. In inequality notation, we would have our variable s. Before the diver has jumped, 0 seconds have passed, and the diver jumps and is in flight. So it kind of looks like this. Here's the diving board. The diver's here and he just jumps off and then he lands in the water. And this time that it takes him to go from the jump to the dive, that's going to be less than or equal to 1.3 seconds. So that's the practical domain of this function. And in interval notation, we would write 0, the interval between 0 and 1.3, and I'm putting it in brackets because we are measuring the time from the jump down to when he lands. Determine the practical range. So now we want to talk about the output values in height of the diver. And so the diver starts off, the highest he ever is, right, is that he is 42 feet from the water. Okay, and we're assuming that the diver walks off the platform. He doesn't jump up and gets higher than 42 feet. So our practical range, which is the variable h of s, the highest that the diver ever was 42 feet above the water. Okay, and then when he lands in the water, he's 0 feet above the water. So the practical range for this situation is the interval 0 to 42. Notice that although 42 feet came first in time, right, when he's over here in the platform, and 0 is the last height that the diver has, we still want to write our range in the proper order, following by putting the smaller number on the left and the larger number on the right. Problem number 2, we have the gas station is currently charging $2.14 per gallon for gas. The function C of n equals 2.14 times n gives the cost in dollars to fill up your car if you pump n gallons of gas. Your car's tank can hold a maximum of 24 gallons of gas. Determine the practical domain and range. So again, using our function notation, C of n equals 2.14n is the equation, and the input variable is n, and n represents the number of gallons of gas that you pumped into your gas tank. And then C of n is our output variable, That represents the cost in dollars to fill the tank. So now what's the practical domain in this situation? So remembering again that N is our input variable, and the most that you can pump if you came in bone dry or you were towed into the gas station is 24 gallons of gas, right? So that's the most. And then the least you can pump is 0 because maybe you got to the gas station and then changed your mind. Okay, so our practical domain goes from 0 to 24, and it's representing the gallons of gas that are pumped at the gas station. And then what's the practical range? Well, it's a cost, isn't it? So if you don't buy any gas, then that's 0. And then what's the most money that you will spend in gas if you fill up the entire 24 gallons? Well, then we'd have to multiply 24 times 2.14 because that's exactly what our equation tells us to do, right? 22.14 times N, and then that amount, so that will give us $51.36 for our practical range. And here it is in interval notation. So you have it inequality notation and interval notation. Okay, one more example. Now we have that the number of unwatched shows in Sylvia's DVR is 85. This number grows by 20 unwatched shows per week. The function n of t equals 85 plus 20t represents the relation between the number of unwatched shows n and the time t measured in weeks. Find n of 4. Explain what this result means. So again, we have this function n of t, which is given by the equation 85 plus 20t. The input variable is t, and t is measured in weeks. T is the number of weeks, and then n of t is our output variable, and that represents the number of unwatched DVR shows, the number of unwatched DVR shows for Sylvia. So then what's n of 4? N of 4. And so we're going to substitute the 4 in for t and do this calculation, and we get 165. So what does it mean? What did we just find? So we've got this order pair 4, 165. And again, remembering that the input variable was number of weeks and that the output variable is number of unwatched DVR shows in Sylvia's DVR. So to interpret, it says that after 4 weeks, the number of unwatched shows in Sylvia's DVR is 165. So I wrote our conclusion statement down. After 4 weeks, the number of unwatched shows in Sylvia's DVR is 165.